Okay, here we go again. You're probably thinking, man, I just watched this video. There's one little difference. The other one was PSAT. This one is PAST, past. All right, so it's focused on the same content or context, and that's PSAT scores. And you know what? The first condition here is that things are normally distributed. And yes, I still have my mouse handling issues, but doing pretty good. Normally distributed. Well, if they are normally distributed, you've got a mean of 500 and a standard deviation sigma of 85, then you can answer questions like this. What score represents the lowest 10%? Represents the highest 5%? Give you the middle 95% of test takers. Ooh, I wonder if I could use empirical rule on that one, probably. But anyway, we're going to focus in on this. And I think really, again, you need to focus in on drawing a picture, hopefully not with a mouse like I'm doing, but score represents the lowest 10%. I don't know exactly where it is, but it's this part. It's this left side, left tail of normal distribution with the mean sitting here at 500 and a standard deviation of 85. Probably not a bad idea to include those symbols, especially when you're taking a test. Now somebody knows that you know this is a normal distribution with a mean of 500 and a standard deviation of 85. Now, in old school, we would ask the table for we would find 10% on the table and we'd work our way backwards to a z-score. And then we would standardize, and you can kind of skip this. You look at it, just it's fun for kicks, standardize. Whoops, standardize. Whoa, standardize. Okay, so yeah, that z got really big because we would use the z-score formula. And we would say the z, or you know what, that negative 1.28, but I'm going to show you a different way, would be equal to, we don't know what score, but we'd like to know with a mean of 500 and a standard deviation of 85. And it's not impossible. In fact, it's very doable. You could then solve for x, and you could find out what score represents the lowest 10%. Okay, so that's the idea. But we're going to go straight to, instead of asking and standardizing, asking the table, we're going to ask the calculator. And we're going to go to second, the second button. And it says vars, but we know that we're using the blue key, which says distribution. And we're looking at a normal distribution here, but we're going to use an inverse process. An inverse kind of implies going backwards from something. And that's what you're seeing here, is that we're working backwards from a percentage to back our way into a score. All right, score. All right, so when you do that, we're going to go to number 3, and number 3 is the inverse norm command. So 3 gives you inverse norm, I think is the way it displays, and we're looking at, these are the prompts: area, mean, and standard deviation. And then it says tail or something to that effect, and it allows you to choose, do you want the left, the center, or the right part of the tail? So that's really good news. Calculator makes this so easy. Well, we wanted the 10%, and so we're going to put 0.1. Some people might interpret that as 1%. We know that is 0.1. You can think of it as 0, but that's 10%. All right, with a mean of, you guessed it, 500 and a standard deviation of 85. Wow, this is terrible. And then I want to know, well, look at the picture. I want to know the left side of this, and voila, we're going to have our answer. And then we can tell our answer in context. One thing that's kind of cool about that is you could have put in, if you knew the z-score, you could have put in the mean of 0 and a standard deviation of 1. No, I'm sorry. That would have given you a z-score, but I don't really want to know the z-score. I'll figure it out later if I want it. All right, score represents the highest 5%. Moving along, we're talking about this area. So what we're going to do is we're going to go over here and put 5% this time, 0.05, and with the same mean, same standard deviation, but this time we're going to use the right side. And you guessed it, when we want that middle 95%, I should have put those bars sitting right at -2 standard deviations and +2. I didn't. But when we want the middle 95%, you guessed it, we're going to put 0.95. These new calculators are, well, they're not new, they're like decades old. But anyway, we're going to put 0.95 with a mean of 500 in the standard deviation, and we're going to use the C for center. And then we're going to be able to tell our answer in context and state the scores. And you got it. Well, that was easy. All right. Goodbye.